Hello, welcome back to Mr. Kenner's online math class. This is lesson 5.2 and we're going to be talking about proportions. Go ahead and turn to the next blank page in your math notebook and put this lesson title at the top. Alright, so this lesson is related to proportions, and proportions are just two ratios. Well, a proportion is when two ratios will form a proportion when the two ratios are equal. So a proportion is just two equal ratios. Go ahead and pause the video here. Make sure you get this definition written down in your notes. And then here are some examples of different proportions. And again, a proportion is just when we have two equal ratios. So 3/4 is equal to 12. 3 to 4 is equal to 12 to 16. And we just multiplied this first 3/4 or 3 to 4 ratio by 4. And the second one, 1 to 2 is equal to 2 to 4. And then 5 to 6 is equal to 10 to 12. So go ahead and write these examples just so you have them to refer to in your notes. Alright, and then now we're going to take a look at the different ways that we can figure out if we have a proportion or not. So there's three different ways to check if two ratios form a proportion. Okay, so you're going to be writing each of these different ways down in your notes. And the first one is to compare the ratios in simplest form. So that means that we need to simplify the different ratios and put them in simplest form to see if they are equal. Okay, so here's an example. We got 6 to 4, or 6 over 4, and 8 over 12. Okay, so if we simplify these two ratios, alright, let's simplify. So 6 to 4, we can divide both of these by 2, and 6 divided by 2 divided by 2, and we would get 3 over 2. And the second ratio we can divide by 4, so we can divide by 4, divide by 4, whoops, and we get 2 over 3. And now they are in simplest form. And you can see quickly that 3 over 2 is not equal to 2 over 3. So these ratios would not form a proportion. So I'll put no here. Okay, so go ahead and pause and make sure you have this example written down in your notes. Okay, so the first way we can figure out if we have a proportion is to compare the ratios in simplest form. The second way is to use mental math. Okay, so when we're using mental math, we just need to compare using multiplication. So for example, in this first example, we have 3 over 4 equals 18 over 20. So in using mental math, we have to ask ourselves, what do we need to multiply this 3 by to get to 18? So this would be times 6. So now if we got times 6 for the top, now we need to do the same for the bottom. What do we need to multiply 4 by to get to 20? It should be 6 as well if they form a proportion, but in this situation it would be 5. So they do not form a proportion. Okay, and then the second example, we have 6 over 9 and 18 over 27. So we ask ourselves, what do we need to multiply 6 by to get to 18? And this would be times 3. And 9 to get to 27 would also be multiplying by 3. So these two ratios do form a proportion. Okay, so make sure you have these examples down in your notes. Mental math allows us to say, what can we multiply the first ratio by to get to the second ratio? And if we can multiply the top and the bottom by the same number, then we do have a proportion. All right, and then the last way we can figure out if we have a proportion is to compare cross products. So proportions will have equal cross products. So if we do have a proportion, our cross products need to be equal. And this is the method that I feel is the easiest and quickest to always get us to see if we have a ratio or not. So when we're finding cross products, we are just multiplying across. So we would multiply 2 times 10, and that would give us 20. And we would multiply 20 times 1, and that will give us 20. So here we do have a proportion because our cross products are equal. In the second example, we have 10 times 18, and that would give us 180. And then we have 30 times 6, which also will give us 180. So yes, these two ratios do form a proportion. Okay, so cross products is a quick and easy way to see if we have two ratios that are equal, which form a proportion. All right, now let's look at some practice problems here. All right, make sure you are writing these examples down with me as I go through them, and we're trying to tell whether the ratios form a proportion. Okay, so for this first example, they're already in simplest form, so I'm not going to use that. I'm going to use cross products. Okay, so I'm going to multiply here. 5 times 3 is 15, and 8 times 2 is 16. So these ratios are not equal, so they do not form a proportion. In the second example, we have 35 to 16, or 35 over 16, and 5 over 2. Again, I'm going to go ahead and use cross products to see if we have a proportion. So I'll start by multiplying 16 times 5. So 5 times 10 is 50, and 5 times 6 is 30. So add those together, we will get 80. And then we got 2 times 35. 2 times 35 would give us 70. Oops. So we do not have a proportion here. All right, and then example number 3, you can use mental math if you want to multiply those big numbers. You can use any of the 3 options here. I'm going to do simplest form. So I'm going to simplify this first fraction by dividing by 3. Divide by 3, divide by 3, and I'll get 1 over 7. Sorry, 1 over 8. This should be an 8. There we go. And now divide the next fraction by 4. Divide by 4. Divide by 4. And we get 1, 8. And now we have these fractions in simplest form, and we can see that yes, these two ratios are equal, so they do form a proportion. All right, you can pause here. Make sure you have these examples written down before you continue. All right, now we need to tell whether these rates form a proportion. So we have 8 feet in 15 seconds, and we have 16 feet in 40 seconds. Okay, so we're going to put them into fraction form, and our fractions are going to be feet on top because they're mentioned first, and seconds on the bottom. Okay, so our fractions would be 8 over 15, and we're trying to figure out if it's equal to 16 over 40. And for this one, I'm going to use the strategy of mental math to figure out if these ratios are are equal. So we're going to, what do we need to multiply 8 by to get to 16? Well, that would be times 2. So 15 should be 15 times 2 to get to, and that would equal 30. So we can see that 15 times 2 is 30, but so that does not equal 40. So this would not form a proportion. Okay, make sure you have this example written down before you continue. All right, are the heights and bases of the two triangles proportional? Okay, so first thing, I want you to pause right now and draw these triangles and with their measurements, and then come back and work through the problem with me. All right, so we're trying to figure out if the heights and the bases of the two triangles are proportional. Okay, so heights is mentioned first, and then bases. So in our fraction, when we create fractions, our height is going to be on top, and the base is going to be on the bottom. Okay, so we have this first triangle, we have 9 over 12, and we're trying to figure out if it's equal to 6 over 9. All right, and then I'm going to do simplest form to solve this problem. So I'm going to simplify both these fractions. This side I'm going to divide by 3, and I'll get 3 over 4. And this side I'm going to divide by 3 as well, and I'll be left with 2 over 3. Okay, so now we can compare. We're in simplest form, 3 to 4 and 2 to 3, or 2 over 3, and that tells us that these are, no, they do not form a proportion. All right, now we're going to look at a couple more ratios to see if they form a proportion. So we have 2 to 4 over 5 and 3 over 4 to 3 over 10. So we have two ratios here, and I'm going to go ahead and use the cross products to tell whether we have a proportion. So this first, I'm going to put them in fraction form. So we have 2 over 4/5, which forms a complex fraction. And then we have 3/4 over 3/10. And now we're going to multiply cross products. So we're going to multiply this way, so we get 4/5 times 3/4. Okay, and we can cross cancel by dividing by 4, which would leave a 1 here and a 1 there. And we would get 1 times 3 is 3, 1 times 5 is 5. Okay, so that cross product there would be 3/5, and then we'll do the other side. And we get 2 over 1 times 3 over 10. And if we multiply straight across, we get 2 times 3 is 6, and 1 times 10 is 10. And if we simplify that by dividing by 2, we get 3/5. Okay, so using cross products, we can see that these ratios do form a proportion. All right, we got one more practice problem here. We're going to tell whether the x and the y in these tables are proportional. Okay, so this is example 1, and this is example 2. And when we're working with tables, it makes it a little bit easier because they're already in fraction form. Okay, so like for example in this, actually before I get there, go ahead and pause now and write these tables in your notes. And now we're going to use mental math to see if they are proportional. Okay, so first we're going to do the x's. So 1 times what would give us 2, so that would be times 2. And then if they are proportional, then the bottom should have the same multiplication. 12 times 2 would be 24, so that works. And then now we'll look at the next set. So we have 1 times 3 to get to 3, and 12 should be multiplied by 3 to get to 36. And that is true, so we do have a proportion here. Okay, now if we look at the second example, we have 1 times 2 to get to 2. So that should be the same in the y column. 7 times 2 does not equal 8. So this one is not proportional.